differential equation. So differential equation is definition is this: a differential equation is an equation that involves differential coefficients. So differential coefficients are this one. Differential coefficients, this is dy dx with respect to x. Y is function of x, and dy dx we write this as differential coefficient of y with respect to x. So this is an equation. So dy dx is equal to cos x. So this is an example of differential equation. d2y dx2 is equal to 0. This is example of differential equation. So there will be variables x, y, then dy dx is a differential equation. This is second order differential equation. This is dy dx whole to the power 4, etc., etc. So this is a differential equation. And order of degree of differential equation. Order is the differential equation is having order is the highest derivative present in it. So order means this is second order, this is second order. So this is second order differential equation, d2y dx2. So order of this equation is 2. Then degree of a differential equation is the highest degree of the highest derivative. So highest derivative here is 2, but its degree is power is 1. This is having power 4. Degree of this dy dx, this is 4, but we consider only the highest degree, highest order differential coefficient, and its degree is 1. So that is why this is a second order and first degree differential equation. So in this way we find degree and order. This one is dy dx is equal to 1 plus x square by 1 minus x square. So here dy dx, it is first order. This is first order and degree is also 1. This is first order and first degree. So order of the differential equation is 1, degree of the differential equation is 1. So here highest order derivative, it is d2y dx2. So order is 2 and degree is 1 because its degree is 1. So then this one you see. So here it is power 3 by 2. So 3 by 2 you need to rationalize this. So you square it. If we square it, then this 2 will go and right hand side will have power 2. So this is whole cube and this is whole square. Then it in left hand side there is it is first order and this is second order. So though it is having power 6, this whole square, if we expand it, we will have this whole to the power 6. 3 into 2 6. But on right hand side this is d2y dx2. It is second order, it is higher than this, and its degree is 2, and that is why the order of the differential equation 2 also the degree is 2. So in this way we find order and degree of differential equation. So these are some examples. These are examples of finding order and degree. Next, formation of differential equation. So formation of differential equation. So we are having this x square plus y square equal to 4. This is the general equation. There is no dy dx, no differential coefficient. Then we need to eliminate this constant. This doesn't have constant, but this is x square plus y square equal to c. It is some arbitrary constant, and we eliminate this by differentiating this one. So x square plus y square equal to c. Then it represents a circle centered at origin. this is x square plus y square equal to c. So if we draw this is x axis, this is y axis, and this is the circle with center 0 0 and radius root over c. So c is any value. So this is one equation. If c is 4, c may be 3, c may be 9. C may be 9 means radius is 3. So this is if it is 3, if it is 2. So these are the general equation. X square plus y square equal to c. This represents a circle centered at origin. So radius may any value. So if we differentiate this, then this c will go. So ddx of x square is twice x, ddx of twice y is y square is twice y, because we are doing it with respect to x, so it is dy dx, and this is equal to 0. So our equation is this. And so what you see, this represents this is a differential equation, and this represents this family of circles. So this is the equation. We are forming this equation from this. Means what? This equation represents this equation. Means this circle, set of circle. So any c, it may be 4, it may be 9, it may be 16, it may be 25, anything. And we say this as family of circle. Radius is any value. So differential equation represents this family of curves. Represented by this. So this is formation of differential equation. So, and we are forming this x square plus y square. We are forming this equation, and when we solve it, we get this solution. This as solution. So when we have a differential equation, we need to solve it, and we need to and this solution gives us the for this particular equation, it is the family of curve. Then so general solution. So so this is x square plus y square equal to c. This is a general solution. But if we give some value to c, say the x square plus y square equal to 4, so this is a particular solution. So x square plus y square equal to c is called a primitive of this equation. Primitive, or also we can say the general solution. So see how to form this differential equation. So we are m and c. We can eliminate m and c, and we have some equation. This is a cos a x plus b. So as in this case, x square plus y square equal to c, we have eliminated c. One constant, so one order. If there is two constants, then we will get a second order. If we eliminate three constants, we will get third order, like that. So see how we are making it. So mx cube plus c. So differentiating this, dy dx is equal to 3m x square. Then m, from this we will write m as this, and this value of m we place here. So this is 3x square. After differentiating this, we get m as 1 by 3x square dy dx. Then again we are differentiating, then it is, because there are two constants m and c, and so we are having this value. We will get a second order equation. In this equation, so 2x plus b. So y is equal to 2 a cos of 2x plus b, and we are eliminating this a, capital A, and small b, and we are having, because we are eliminating two constants, and we get a second order equation. In number 3, we are eliminating three constants, a, b, c. So a, b, c, we are removing it, and we are getting third order equation. So this is the way of forming an equation. Say y is equal to a plus b by x, then differentiate it. We are getting b value, b is expressed as minus x square dy dx. Then also from this b is x cube by 2, this one. Then we equate this b and this b, and we have this equation. So this is the way of forming differential equation. See how it is done. Dy dx is, we are differentiating this, then we are having this one, then d2y dx2, and this is the equation. So from this we are having this equation, d2y dx2 equal to minus 9y, and primitive of this is from which equation we are getting this differential equation. That equation is called primitive or solution. So we can try these values. So this order and degree. So order is 3 and degree is 6. Here order is 4 but degree is 1, because this highest order is having 1. So these are some examples you can try. Now we need to solve it. When differential equation given, we need to solve it, and various type of differential equation. So every equation, so differential equation of first order and first degree, this is the method how to solve the equations. And to solve it or to form a differential equation, we need derivatives and integration. So in case of solution, so this is a differential equation, we need to integrate it. When we integrate, then only this dx differential will go. Then x dx, so its solution is, you just integrate, then this dy dx will go. And you need to remind the values, this integration and derivative. Integration and derivative, and we need to do. So these are the formulae. You need to remember. So ddx of x to the power n plus 1 by n plus 1. When you take the derivative of this, we get x to the power n. And integration of x to the power n is x to the power n plus 1 by n plus 1. When we take derivative of log x, when base is e, it is 1 by x. And integration of this 1 by x is log x to the base e. ddx of e to the power x is e to the power x, and integration of e to the power x is e to the power x. So these are the equivalent formulas. So when we know this, we get this one. So this is derivative formula and these are integration formula. We should know these values. So the integration of sin x is minus cos x, and ddx of cos x is minus sin x. This formula, this you should know it, and then you can solve the differential equation. These rules also, these are the rules of differential equation. These examples we did it. This all these things are you have learned in your previous semester. These are the examples we solved. Then method of substitution is there with this method. So this is the formula method of substitution. Integration of fx dx. So you should know all these things, and then only you can you remember, you go through these things and you can solve this differential equation as well as form the differential equation. So to form the differential equation, you should know the derivative, and to solve, you should know the integrations. So these are integration problems you can have. See, these are trigonometric functions we are integrating. So integration of, so this is product, and product we are converting to sum. Then sum, we can separate the integrals. So then we are substituting this. And we again put the formula. So cos twice x, we know the integration of cos x, not cos 10x. So cos 10x, so 10x we are substituting. So it is cos t dt. Then it is integration is, then we have sin t, or sin t means in place of t again we write tan x. So these are method of substitution. So you should know all these things, and then we can solve the differential equation. Then, so differential equation where variables are separable. So dy dx. So dy dx. So suppose this is an equation. So this is equation. We write x. This dx is differential of x, and dy is differential of y. So variables are separable. Means what? With functions x, we need to get dx, and with functions of y, we need to get dy. Then only you can have this one, integration of x dx equal to integration of y dy. So first we should make in this way. From this you derive like this, then you write solution is. So when a solution part, you write the integration side, and then make this integration. So integration of x dx is x square by 2, integration of y dx is y square by 2, and you write one arbitrary constants. And after solution, we are getting x square by 2 minus y square by 2 is equal to c. Then x square, so from this we are having x square minus y square by 2 is equal to c, then twice c. So we will get x square minus y square is equal to twice c, and in place of twice c we write the capital, this is c. So this is the solution of differential equation. So this is variable separable. This one, so dy by y, dx by y, x. So with dy only y's are there, with dx only x are there. Then solution is this. So integration of 1 by y is log y. So that is why we need to remember the formula. So integration of 1 by y, it is log y, and this from the formula chart, you see this one. We did this formula search. We did have this formula. It is this one, number 2. So integration of dx by x. So integration of dx by x is log x. So we are applying this formula. These are basic formula. Then log y is equal to log x. Then this is arbitrary constants. We are writing log c, so that we can multiply cx, because log a plus log b is equal to log ab. So we write, so this is our, so log y is equal to log cx product. Then we eliminate this log and we have y is equal to cx. Next one is dy dx is equal to y into power x. Now we write with dy, we write this 1 by y. So this is dy. So if we simplify this, what do you get? Number 3. What will you get? What do you get? dy plus y e to the power x into dx is equal to 0. So e to the power x dx, this y you take it down, so divide by y. So we have now this one. So dy by y, and this y goes, so it is e to the power x dx. So variables are separable now. Now you write the solution. This is solution is dy 1 by y, then it is e to the power x, and integration of this is log y, and integration of e to the power x is e to the power x. This will come from the formula. So this is the solution. Dy dx, so same procedure. So this will be number 4. This will be what? Dy plus y plus x square y, with this dx will come as product is equal to 0. Then y divided by y, will get dy by y, and this y will go, this 1 plus x square dx. So with dy only 1 by y is there, and with dx only 1 plus x square is there, and then you make the solution. So when you do this, you remember it's like this. But if you this is because it is plus, we can write like this. If it is product, then we can write like this. Product is different. Plus for plus only, it is, because when it is plus, we can take it to both sides. This is dy by y minus 1 plus x square dx. Means what? We are integrating, and that is why when this is plus sign, we can write it as this. So these are very simple. You cross multiply it, you will get here 1 plus, this implies 1 plus y square. Cross multiply it with dy is equal to, on right hand side it is 1 plus x square dx. Then solution is integration of 1 plus y square dy 1 plus x square dx, and solution is, it is integration of 1 is y, integration of y square is y cube by 3, integration of y is x, integration of x square is x cube by 3. Then this one is sec square x tan y dx. So this y, tan y, so tan y we remove from this, and this tan x you remove. So you divide this by, so we are having it like this, divide by sec square x tan y dx plus tan x, or what you can write, if you take this to left hand side, right hand side, if we take this to right hand side, sec square x tan y dx is equal to minus tan x sec square y dy. Then you divide by this tan y, you take to right hand side, because dy is right hand side. So tan y you divide by tan y, and this tan this you divide by tan x. So we are dividing by tan y and tan x. So tan y will go from this, and tan x will go from this, and we get sec square x by tan x. So with dx we are having these x's, and with dy we are having these y's. Now your solution is integration of this plus integration of this. Now integrate it, and this one is, it is by method of substitution. So tan x is, you write tan x is equal to z. Then its ddx is sec square x dx সমান, this method of substitution. So for this integration we write this we write as integration of dz by z, and dz by z is log z. Z is our tan x, so it is log of tan x, and this is in this way it is log of tan y. Same procedure, and because all are log, we are writing as log c, so that we can eliminate this, because log a plus log b means log of ab, so log of tan x into tan y, and then we eliminate this log sign. Next, this problem we see e to the power x plus y. E to the power x plus y, it is product, e to the power x into e to the power y, and then like this previous one, like this one. So we dx, this we can write as this implies e to the power x e to the power x e to the power y dy plus dx is equal to 0. Then e to the power x multiply by e to the power minus x, or you divide by e to the power x. So we will have e to the power x will go e to the power y dy plus e to the 1 by e to the power x means, or 1 by e to the power x dx is equal to 0. And these are going to right hand side, means it comes minus, and this e to the power 1 by e to the power x means e to the power minus x, and then integrate. So solution is now integration of this e to the power, integration is e to the power y, then this integration is e to the power minus x. If we write minus x is equal to t, then minus dx is equal to dt, then integration of e to the power minus x, then minus you take inside, dx common, in place of minus x we write t, then in place of minus dx we write dt, so it is e to the power t is equal to e to the power t, and this is equal to, in place of t we write again e to the power minus x, sorry, e to the power e to the power minus 6, yes, e to the power t, yes, this is e to the power it should be e to the power minus 6, so this is equal to actually this is equal to e to the power minus x plus c from this one. So this is the way of solving it. Now number 8 we see x plus y whole square. In this case we substitute this as x plus y is equal to z, then dz dx with respect to x, dz dx common, so derivative of x is 1 and derivative of y is dy dx. Or dy dx you can write dy dx is equal to dz dx minus 1. So we are substituting this. So in place of dy dx we are writing, in place of x plus y whole square, s square implies, so dy dx plus 1, So x plus y whole square. So we are adding x plus y whole square. Here again we are adding x plus y whole square. So here we are substituting v, not z actually, and it is v square not here, it is z, we are writing z here. So z square dy dx, this is dz dx or dv dx, then a square plus v square. Simplify it, we will have this one will be, this implies v square dv is equal to a square plus v square dx. So v we need to take to left hand side, so it is v square by a square plus v square is equal to dx, and variables are separate now. So solution is integration of, this is with respect to v and this is with respect to x. Now we need to integrate this one. So integration of this is, we need to have some simplification. You see, v square we write as a square plus v square minus a square, then a square plus v square by a square plus v square, it is 1, and minus a square by a square plus v square, this is equal to, right hand side is simple, it is integration of dx, then integration of dv is v, and integration of 1 by a square plus v square, it is in terms of tan inverse function. So it is minus a square, then formula is 1 by a tan inverse b by a, and right hand side is x plus c. We substitute now v as x plus y minus, in place of v we write x plus y. So this is our solution. And this you can try. Derivations are given like this. We are factorizing this. We are getting 1 by x into 1 plus y, 1 minus x into 1 plus y, and with dy we write 1 plus y, so we have to divide this, then 1 minus x into dx, then we are getting variable separated, and we are having this. Then number, this one twice x plus 4, this is variable separated, integrating it, and the solution is this. So these are some exercise you can try. You can have some hint here. This is simple. This will exercise grouping x 1 y dx, exercise grouping 1 2 added letter. So number 1 we can try as, this is dy by y is equal to dx by x. So it is log y equal to log x. This we will write as dy by 1 plus y square is equal to x dx. So solution is integrated, it is tan inverse y equal to x square by 2 plus c. Number 3, it is y dy by 1 minus. So here variable separated will be, here we separate the variable as, it is y dy number 3, it is y dy by 1 minus y square plus x dx by 1 minus x square equal to 0. So solution will be integration of y dy by 1 minus y square is plus integration of x dx by 1 minus x square equal to, integration of 0 is constant. Then what we will have, method of substitution, it is 1 minus y square is equal to t, you can write, then this is 0 minus 2y dy, so it is half of minus half of dt plus integration, if we write as u, 1 minus x square as u, this will be minus half of du equal to c. Then minus half, you can take it, this is other, so minus half u, then we write this as integration of dt by t plus integration of du by u is equal to, because minus half is constant, so you take to right hand side, you will get another constant, see this. Next you write, it is log t plus log u, this you can write log of say a. Then after that you can write log of tu, so log of tu is equal to a, implies tu means t is our 1 minus y square, t u is 1 minus x square is equal to, so this is sorry, log tu is log a, we write log a, so log is going, so this is equal to a. So this is the solution, we are eliminating this dy dx. Then number 4 is, it is like example 8. Then number 5 we can have, this is dy by root over 1 minus y square is equal to dx, we are cross multiplying it, dx by root over 1 minus x square, and after integration we will have in this formula is sin inverse x sin inverse y. Then number 6, I will erase it, erase this. This you can write as, this you can write as dy dx whole square is equal to 4 minus y square. Then take the square root, we will have dy dx is equal to root over 4 minus y square, and then we can write dy by root over 4 minus y square is equal to dx. So solution is this will be in terms of sine inverse and this x. So these are the way of solving this. This is method where variables are separable.